Hello everybody, today we're going to be talking about one of the most common sorting algorithms, merge sort. This presentation is brought to you by me, Robert, and Suhas. Let's dive right in. Merge sort is a common sorting algorithm that uses a divide and conquer strategy to work through the data, as it divides the initial array into chunks and then operate on those chunks to derive the result. Due to the nature of the algorithm, merge sort is a recursive algorithm. It repeatedly divides the initial array into smaller subarrays until it reaches individual elements. From where on, it starts to compare and repeatedly merge until we arrive at a complete sorted array. Merge sort is also not in place, as the elements in the initial array can be stored in different locations throughout the sorting process. It is, however, stable, as the algorithm sorts from left to right, so the different occurrences of the same element stay in order at the end of the sorting process. Two examples of merge sort can be seen on the right hand side, with an odd length at the bottom and an even length at the top. We can see that the odd length has an extra element that just gets stored individually until the very end where it gets merged. Now let's talk about the time complexities. The time complexity of merge sort is O(n) log n for all case scenarios. This means that the algorithm will take the same amount of time for all types of data. For example, if we input a completely sorted array, it would take the same amount of time to sort as an unsorted array. This is because it would need to go through the same steps every single time regardless of what gets put in.
Hi, I'm Robert, and I'll be working through a code example of merge sort. Basically, as you've seen in the previous slides, merge sort works in two halves. First, it breaks up the main array into multiple tiny arrays, eventually of size 1, and then later it recombines these small arrays into the original array again, but now it's sorted. So the parameters of the merge sort function are the array that you want to sort and the starting and ending indices for the region of the array that you'll be looking at. The merge sort function breaks up this array into tiny pieces recursively, so a termination condition is needed. This is when the starting index is greater than or equal to the ending index, and this just makes sure that the function doesn't continue to run past the point that the array is completely broken up like this. Then the middle index of the array is found, and using this middle index, the merge sort function calls itself over its left half and over its right half. So this will keep recursively happening until this termination condition is reached and all the arrays are just of size 1. So you can see this here where the original array breaks up into the left half, right half. Then here it breaks up again into left and right, and then again left and right where it would terminate because it's of size 1. After this, the function needs to merge all of the elements back together, so it will call a merge function, which I'll talk about in the next couple slides. The code for the merge function is a little more complicated, so instead of the actual code, I'll just go through the pseudocode. The parameters for the merge function are the array and the starting, middle, and ending indices for the region of the array that you'll be merging and sorting. First, two new arrays will be created representing the left and right halves of the region that you're looking at. The data from the original array will then be copied over into these two new arrays. This is needed because the original array is going to be changing as it is sorted, so the original parts of the array need to be preserved so they're not overwritten. After this, both arrays will be iterated through simultaneously, copying the smaller element to the main array. I'll go through an example to show exactly how this works. For this example, we're looking at these elements of the array, which represent the first 4 elements of the array. The left and right arrays are 3, 7, and 2, 16, which were sorted in the previous iterations of the merge function, right here. Now we'll iterate through both arrays at the same time and copy over the smaller element. So starting with 2 and 3, 2 is smaller, so 2 is copied over here. And now we move over to 16. So comparing 16 and 3, 3 is smaller, so 3 is copied over. Now comparing 7 and 16, 7 is smaller, so 7 is copied over. And now we're just left with 16, so 16 is finally copied over. So now we can see the first 4 elements of the array are sorted. And eventually, after this entire right half of the array is sorted, then the left half and right half will merge to recreate the original array, but now the entire array will be sorted.
So now that we know how merge sort works, here's a little review of what we need to remember. Merge sort is among the divide and conquer algorithms. It divides the input array into half and calls itself on both halves. This process is done recursively over the entire array. So when we're done, all the individually sorted pieces are merged back together to form the fully sorted array. So for example, we have an unsorted array of integers here. If we apply merge sort to this data, it's going to recursively split the array into half until we have done this over the entire length of the data. At this point, it will then start merging the arrays together in the correct sorted order. When we want to look at the functionality, the process looks something like this, in which the numbers on the arrows are indicating the steps in order of how it is executed. Now that we understand the functionality, we can go into the implementation. The merge sort algorithm will make use of 2 methods. One is a recursive merge sort method, and the other is a merge method, which will merge the halves of the array back together to form the completely sorted structure. For example, if you had a merge sort method, we take in the array and the length of the array. Since it's recursive, we will need a base case, which is simply to check if the length of the array is 1, which therefore means that we can't possibly split the data up any more than we already have. If not, then it'll go about splitting up the arrays and calling merge on them. The merge method simply takes in our 2 subarrays and the original array that we were sorting and merges them together. Finally, we can talk about the complexity when using the merge sort algorithm. The merge sort algorithm, like most divide and conquer algorithm, is quite a fast sort algorithm. Merge sort has a worst, average, and best case time complexity of O(n) log n. One thing to take note is the fact that merge sort requires an amount of additional space that is equal to the size of the unsorted array. This means that merge sort requires O(n) of additional storage, where n would be the size of the array we are sorting. For this reason, I would say merge sort isn't exactly a recommended algorithm to use for sorting extremely large data sets, which is why merge sort is the preferred method for sorting linked lists due to the way the memory functions in a linked list as compared to an array.